Alrighty, welcome to the fourth video in this sequence. This one's going to talk about adding exponential expressions. So if you remember, an exponential expression is just something that has a base, which is the number that you multiply over and over, and you're raising it up to an exponent as the power, and the exponent tells you the number of times that you multiplied. So the rule for adding exponential expressions is it's just like combining like terms. So in order for the exponential term to be considered a like term, like terms, both the base and the exponent have to match. Okay? And if they do, then you add the coefficients, and if they don't, then you can't do it. So I'll do some examples right here. So let's do x to the third plus 2x to the third. Okay? The base is x, and the exponent is 3. So here I've got x to the third, and here I've got x to the third. And so they match. The base is x in both cases. The variable, the exponent is a 3 in both cases. So the base and the exponent matches. We add the coefficients. Well, this one doesn't have a coefficient, so automatically the number in front is a 1. So 1 plus 2 equals 3, and I have 3x to the third. So we add the coefficients. I should put and keep the base and exponent the same. So let's hold on. What's up? I took the banana bread out like half an hour ago. It's fine. I mean, I'll just erase this part. I could leave it in though if you want. Yeah. You can talk to me. I mean, if you need to get my attention, I can always delete stuff. Okay, let's do another example here. Let's do 5a to the fourth plus 3a to the fourth minus 9a to the fourth. Okay, so we start looking and see what is our base, what is our exponent. Our base is a, and our exponent is 4. Base a, exponent 4. Base a, exponent 4. So all three of these, 1, 2, and 3, are like terms, and so we can combine them. So we'll just start with the left and go to the right. I have 5a to the fourths here, and I'm adding 3 more a to the fourth. So this here is a total of 8 a to the fourths, and then I'm subtracting 9. So 8 minus 9 is negative 1. Negative 1 of what? A to the fourth. So sometimes I like to think of my base and exponent as like an object. So when I look at this, I think x to the third, that's probably like a radio. So I have 1 radio plus 2 radios equals 3 radios. So if you visualize in your head that this whole thing, x to the third, is just some object, could be a radio, could be a fish taco, could be a candy cane, it doesn't matter. 1 candy cane plus 2 candy canes equals 3 candy canes. So it's staying exactly the same, and you're just adding and seeing how many of them you have. Maybe a to the fourth is an apple. 5 apples plus 3 apples minus 9 apples equals negative 1 apple. Now, my shape of my apple is a to the fourth. That's okay. But that's the way, it's a good, easy way to think about them. Okay, let's do a couple more examples of adding exponential expressions. Let's do x to the fifth minus 3 x to the third plus 6x to the fifth. Okay, so now I've got here x to the fifth and here x to the fifth. So those two match up, but here I've got x to the third. X to the third is different than x to the fifth because the exponent does not match up. So I cannot combine this one with either of these two, but I could combine these two with each other. So here I have 1x to the fifth, and here I have 6x to the fifth. So that's a total of 7x to the fifth minus 3x cubed. So this guy I cannot combine with this guy because this one is x to the fifth and this one is x to the third. So my final answer is just going to be like that, keeping these two separated. Okay, how about 5s plus 10b squared minus b squared plus 6s. Okay, 5s plus 6s. This s, if you don't see anything there, it's automatically the first power. So the 5s and the 6s can be combined into 11s to the first power. And then these two, they both have a b squared, and so I can combine them. 10 minus 1 is 9, so plus 9b squared. And I cannot combine my s's with my b squareds because these are maybe snakes and these are maybe square-shaped bananas or something weird like that. So again, for me it helps a lot to visualize these as objects, and then the number in front is just how many of them I have. So I have 5 snakes plus 10 bananas. I take away a banana and I add 6 snakes. So I had 5 snakes and I added 6 snakes, so I have 11 snakes. I had 10 bananas and I took away 1 banana. I now have 9 bananas. So it makes it more concrete and easier to visualize that you're actually adding or subtracting an amount of something. And this is going to be very different than when we start multiplying and dividing. But adding and subtracting, you can think of it as actual physical objects that you're adding more of or taking some away. So that's it for adding exponential expressions. Just remember you can only combine them if the base and the exponent match, and then add the coefficients if they do.